So I come to you today from the traditional lands of the Camaragal people, and in the spirit of reconciliation, we acknowledge the traditional custodians of the country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past, present, and emerging, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Thank you for joining, everyone. Welcome to the OutSystems User Group Sydney. Today we have AWS Dev Tips, learning from the experts. We have 4 presentations. We'll start off with Jacques van der Merwe. He'll run us through an AWS overview. We've got Osama Ghanem. He'll show us an AWS use case with OutSystems. We've got Stuart Harris that will show us how to use up all our bandwidth using streaming video from AWS S3. And then we have Rafael Haniheri right at the end showing us AWS enablement and certifications related to that. At the end of all of that, we'll have a Kahoot session, so pay close attention to the presentations so you can answer all the questions and have a swag kit, perhaps. Cecilia? Yeah? If you win, you get a swag kit. And it's really cool. So yeah, pay attention. I've been asked that we all keep our microphones on mute. Videos on if you want. We like to see friendly faces. Makes it more community-like. And please feel free to share your questions in the chat. And we'll try and get to all of them if there is time at the end. Otherwise, we will try and arrange something offline or asynchronously to get those answered. Cool. Thank you. Over to you, Jacques.
Thank you, Hanno. Thank you. I think we can move to the next slide, if you will. As Hanno said, my name is Jacques van der Merwe. I'm a Senior Solution Architect. There we go, at Phoenix DX. I'm also the AWS lead for Phoenix. So just want to share a couple of AWS related things with you before we get into the depth of this. AWS has obviously been around for a while, but they are adding services thick and fast, and it's an ever-changing landscape. So yeah, next slide, please, Hanno. So OutSystems and AWS together, it is actually quite an extensive relationship that OutSystems and AWS has. In AWS, OutSystems went onto the AWS cloud in 2008 already. So I don't know how many people know, but in 2008 the cloud was really a very dare I say, fictional thing. Not many people even used cloud as a term in that stage, but OutSystems went there quite some time ago, and obviously has a lot of experience because of that. In 2020, they signed a strategic collaboration agreement, which really made them a tier 1 ISV for AWS. What that means is that customers can buy OutSystems through the AWS marketplace and through their procurement channels, which has various implications. One of the biggest things was actually that the AWS sellers started pushing OutSystems sales as well, which really strengthened the community quite substantially. Everyone also knows, I hope, that the new ODC platform is going to run natively on AWS, which is really the next big step in the AWS journey. That is moving from server infrastructure to serverless interface, building on those core AWS capabilities. Also interesting, OutSystems won the Partner of the Year award for Asian region, which is a very significant thing if you consider that there is more than 200 ISVs in that top half of the sector where we are measured against. So that is a significant achievement for OutSystems. And then the interesting thing is the conversation paths that exist for customers moving their on-premise legacy things into the AWS cloud. That is really part of the biggest motivation for this partnership. I mean, it is good for OutSystems to have that AWS infrastructure underneath it, but the possibilities that exist because customers can migrate quite easily is really why OutSystems is pushing this agenda. Next slide, please, Hannah. So there's a handful of reasons why it matters, but these three things really stood out to me initially. The refactor, rebuild of the core systems is obviously what we do as developers, and that is I want to say the most important part of this conversation. I think especially when it comes to that refactoring, rebuilding, a lot of customers are stuck on those old applications, and they simply put it in the too hard basket to move it to the cloud. With something like OutSystems, you can really accelerate that thinking, and because of the rapid development that you have in OutSystems, you can make those dreams really come alive and move people into the cloud. The other interesting angle on this is the talent pool itself. So because AWS is quite successful at what they do, they struggle to keep skilled resources or get enough skilled resources in the AWS space. Now, because OutSystems run on AWS and we are OutSystems developers, we can build in the AWS realm without necessarily having that core AWS skills. So we can use OutSystems talent to augment and enhance the AWS talent pool. So it really makes enables customers to get access to a larger group of people to develop those solutions that they build to replace their core systems. And then, of course, the quicken innovation. AWS, like I said, they start up new services very often. I want to say daily, but I don't think it's that often. But every time I check, there is a handful more services available, and all of them are very innovative. With OutSystems, we can consume those innovative services really rapidly, and enable customers to make use of those things. The use case that I know Osama is going to talk about is one of those examples where everybody, I think I stand corrected, but the topic is facial recognition. Everyone is aware of it. Everyone knows what it does because it's on your phone and devices that we use frequently. But when a customer wants to use facial recognition in an application, they frequently say, how do I do that? What do I need? Where do I get the skills to do that? And that is where OutSystems comes in, and it really makes a difference to the customers. Thanks, Anu. So at the moment in the Forge, there is these 10 AWS services available, which is supported by OutSystems themselves. There's quite a bit more available, but these 10 on the screen at the moment is the ones that OutSystems support. And it is also, if you look globally at the usage of AWS services, it is amongst the most commonly used services, except for EC2. I'm not sure if you're familiar with the EC2 service, but it's basically a virtual machine on the AWS infrastructure. So anything that you lift and shift will probably run on an EC2 instance. But for that reason, it is not really a Forge component because we don't really interact with virtual machine operating systems per se, but rather the components between them. So I just quickly want to run through these things. Just I think, in my opinion, AWS has the habit of giving them weird and wonderful names, and it's not always that obvious what these services do. So I just want to introduce you quickly to these to this 10 services. And hopefully you find something that might be useful for you in the future. So Transcribe It's kind of self-explanatory, but it's an Amazon speech recognition service that uses machine learning models to convert audio to text. The best use case for that is probably, if you think subscripts on a television, it allows you to do things like that. I know that this Google Meet that we're in at the moment has a transcribe functionality as well, so you can actually see the text on the screen as you go. Textract is a machine learning service that automatically extracts text and handwriting data from scanned documents. So think OCR, if you've got invoices or scanned letters, things like that, it can extract the text and make meaning of the content in that. The Lex service helps you build conversational interfaces like chatbots. Most large companies nowadays have chatbots on their website with which you can interact with. So Lex is a service that allows you to do that. Poly is, again, the opposite side, turning text into speech. So if you think Alexa or Siri, where the machine is talking to you in audible voice, Poly provides you with that service. Translate, I think, is self-explanatory. One of the cool features about Translate, it is really a very efficient engine in translating. So it does it very quickly, which allows you to translate text almost real time what people are speaking. It's like literally a couple of seconds lag. So I don't know if anyone saw the PowerPoint as an example have built-in translation features where you can, while you do your presentation in one language, it will translate the subscripts to another language at the bottom, which is quite interesting and very effective if you do presentations across multiple regions. But the Translate service is capable of doing that. SNS is the Amazon Simple Notification Service. It's a managed service that provides message delivery from publishers to subscribers, sometimes producers and consumers. So it is really facilitating that notifications that if you need to send it to consumers or your users out there, and it facilitates all mediums of notification. The SQS is a simple queue service. Lets you send, store, receive messages between software components at any volume without losing messages or requiring other services to be available. So it's really ensuring those delivery between your systems, very efficient. It is highly used throughout the world at the moment, a very good service to be aware of. S3 is probably the second most common service that Amazon uses, which is really just a object storage service, which is highly available, highly scalable. So you never need to worry about your objects being slow to deliver or offline. S3 is very reliable and probably one of the most common storage mediums available. Glacier is an incarnation of S3 storage, which is just a secure, durable service for low-cost data archiving or long-term backups. However, there's 3 versions available of Glacier. There's instant retrieval, flexible retrieval, and deep archive, which really just talks to the speed at which the data returns, but it also factors the cost for those services. So the slower the return, the less you pay. And then finally, the Kinesis service, which allows you to analyze data and video streams in real time, but more specifically, it's for media streamed from your connected device into AWS. So there's various devices, if you think Internet of Things, IoT devices, those real-time streaming data, Kinesis allows you to verify those streams, whether it's video, audio, or just data, and analyze them real time. It is an extremely powerful service, and like I said, it is available in the Forge today, supported by OutSystems. And I think that brings me to the end of my part. Dead on time. Thank you, Hanno.
Thank you, Jacques. That was really insightful. I thought I knew a lot about AWS services available, but yeah, I've been proven wrong. Thank you for that. It's really insightful. Right. Any quick questions? Will we give a minute for questions? If there's anything obvious, then we switch over to Osama for the next bit. No one, nothing. Going once, going twice. Okay. Thank you, Jacques. Osama, you're in the hot seat.
Thank you, my friend. Thanks, Jack. Thanks, Hanno. Welcome all again to the user group. A brief introduction, I guess, to myself. I've been working on OutSystems projects for the past 8 years now. I've had the privilege of working on different sides of the coin when it comes to OutSystems customers and OutSystems partners. So I was able to extend my reach, I guess, into a lot of different industries working with OutSystems, and some brings us to today where I am with the Phoenix DX and the use case I'm going to talk about, which is a Phoenix DX customer in service security. So next slide, please, Hanno. Before we jump into the use case itself and talk about how we implemented it, I wanted to define facial recognition first. So first of all, facial recognition is a form of biometric security which can confirm an individual's identity using their face. Now, this is not a groundbreaking concept. We've been using facial recognition on our mobile devices for a while now, to unlock our devices. However, previously, facial recognition was a feature that you wouldn't see very often because of how hard it was to tap into. So you would only see it in extremely expensive enterprise level security systems, like what you find in airports, for example. However, nowadays, because of its ease to integrate with, thanks to tools like AWS Recognition, which is another service that I'll be delving into a little bit more details later, it becomes very easy for us, OutSystems developers, to leverage that capability in our mobile app. And that's exactly what we did here for security, and specifically for the BOSS time and attendance mobile application. Next slide, please, Hannah. BOSS time and attendance, as the name suggests, is an application which allows guards to manage their time and attendance on shifts. So it allows guards to check in and check out of shifts. The app essentially captures all that information that the guard goes throughout the shift for compliance requirements for service to use eventually. So an example use case would be a guard would arrive on site for the shift, a security guard would arrive on site for the shift. They would launch the BOSS time and attendance mobile application, and they will select the shift that they want to check into. And then once they commence that process, the facial recognition step kicks in. There's their front-facing camera opens up. There's an avatar outline that appears, and the user has to align their face with the avatar, with the outline. And as soon as the face is aligned, the application automatically captures the picture and sends the picture over to AWS. Now, the image plus some of the data that we send alongside the image goes through a lot of different AWS services, and we're going to touch on that in the next slide. It is a system that includes various AWS services that work together in order to provide the scalable functionality that we have at BOSS. And the result is 75,000 verifications a month, and that number is still growing. Sub 1.5 second verification. So each of those facial verification runs average 1.5 seconds, and the accuracy rate is 99.2%. These numbers are growing. And as the technology continues to improve, so AWS recognition specifically, the accuracy rates continue to grow. The time it needs for the facial verification to run decreases, except for becoming more and more efficient. Next slide, please, Hannah. So how does the solution work? we've got two main pieces of the puzzle here. We've got the OutSystems side and we've got the AWS side. Now, I'm not going to delve into a lot of details on how this was built in OutSystems, since I want to focus on the AWS piece. However, on a very high level, the way the solution was built in OutSystems is what you'd expect for an application like this. So you'd have an OutSystems mobile app. Inside your OutSystems mobile app, you might have a few modules. You might have an end user module, some core modules, maybe core service, or core widgets, etc. And you would have a separate application for your facial recognition connector, which, as we know, in OutSystems, a connector is an application that encapsulates an API that you then leverage inside your OutSystems applications. So the API we use here in this specific scenario, the AWS API, is defined inside our FR connector. If you've got business logic that needs to go on top of your connector, then you might have an FR core services, for example, module where your API is further abstracted, or there might be some business logic concepts that you need to integrate into this feature before feeding it into your main mobile application. And then if you've got a user management tool, where a lot of organizations that have large OutSystems factories do nowadays, then it would make sense to integrate this facial recognition capability into user management. And an example of this would be when users first sign up for facial recognition in the mobile app, they need to take a reference image. This reference image might end up being their profile picture, for example, and that's where their user profiles in the user management system can be enhanced. Now, this is how things would be structured on the OutSystems side. On the AWS side, we can see the 6 services that I mentioned previously. We have Amazon CloudWatch, Amazon API Gateway, Recognition, Lambda, RDS, and S3. So what are these services, and what do they, what part do they play in this process? If we can go to the next slide, please, Hannah. Let's start looking at the toolkit. So starting with Amazon Recognition, this is the star of the show. This is the service which runs the facial recognition comparison. It also has classification capabilities, by the way, if that's something that might interest you. And obviously, as you'd expect, it is the main, it's the beating heart of this entire flow. It's responsible for providing that comparison rate at the end, which is typically a percentage of how similar the reference image is to the image that was just captured. And then we can deal with that data accordingly. Secondly, we've got AWS Lambda, which is a compute service, which lets you run code in various development languages. It's an incredibly powerful tool, and in our use case here, we use Lambda as an orchestrator. It's the glue, really, that brings all of these different services together, and you'll see what I mean when we go to the next slide. But it orchestrates the entire flow. So we need to tap into S3, it happens via Lambda. We need to tap into RDS, it happens via Lambda functions. So everything lives and happens within Lambda, and we'll see how that works in a second. Thirdly, Amazon S3. So like Jack mentioned, one of the most common AWS services, S3. And by the way, Stuart is going to be delving into S3 in a little bit more detail as well, so make sure you stay tuned for that. But in our use case, well, first of all, S3, to define it, is an object storage service. It allows you to store images, videos, documents, etc. And the use case for S3 in this flow is to store the images that users are capturing. So when a guard takes an image for the facial recognition process, when this image goes to AWS, it gets stored in S3. Now, you might ask here, well, what about privacy? Is it, safe to store images in S3? And the response we have for that is there is a purge function in Lambda, which periodically goes through images that were captured by boss and deletes those images after a specific period of time. And that way we ensure that we're not storing any images for longer time than they're needed, really. Fourth component, Amazon RDS. So RDS stands for Relational Database Service. Say that quickly 3 times. And basically what this is an AWS service which allows you to create relational databases. And we use this in this flow to keep track of all the historical facial recognition records that are happening. So it's more of kind of an auditing kind of mechanism where we store all of the historical runs the comparison rate. So if you ever wanted to run a report or see how many facial recognitions that have been done in a specific period of time, the average comparison rate, whatever it might be, we can always refer to the data we have stored in RDS. We then have the API gateway, which is the entryway essentially to all of these services from an OutSystems perspective. And in API gateway, you can create APIs, you can maintain APIs. There's a lot of options and customizability in terms of what your API, how you want your APIs to behave, and that's all managed inside the API gateway. Last but not least, we've got CloudWatch, and CloudWatch isn't a key service that's used in the flow. However, it's an important one for us to keep an eye out for all the other services. So it helps us monitor all of these different components, so we can ensure that the processes run correctly. There's no bottlenecks anywhere. The whole point of the solution to be scalable. So we want to ensure that we're not running into anything that we shouldn't be running into, and that's how CloudWatch helps us with that. If we can go to the next slide, please, Anna. Thank you. So how do all of these kind of tie into each other? Well, first of all, systems application sends through the image, sends through some other supporting data into AWS. This goes through the API gateway, of course. There's an authentication function that gets triggered first, which essentially, like you expect with any API, just authorizes the user that's trying to consume it. We then tie into an AWS Lambda function, and that's where that orchestration that I mentioned before kicks in, where Lambda starts firing off requests to all of these different services. So we first check if the user exists in our RDS table. If they don't, we create them. If they do, then we create that new record for that facial recognition run. We then store the image that we just passed through in that API call into S3. Thirdly, we run that comparison. So we take the image from S3, we take the reference image, which also gets passed through, by the way, in that API call, and then we send both images to Amazon Recognition, which again is the tool that runs that comparison. The comparison happens, we get back a comparison rate. Again, that might be a percentage of some sort, and then that result is saved in RDS for future reference, and then eventually that returns back to that comparison rate returns back to OutSystems. So as you can see, there's a lot going on the AWS side. There's a lot of components talking with each other. This maybe puts the 1.5 second flow, makes it a little bit more impressive, I guess, since everything's happening incredibly quickly, and this is only going to become faster and faster as time moves on and technology evolves. We could have always, just used API gateway and tapped into RDS directly, for example, not needing to bring in Lambda or S3 or, Recognition, obviously we do, or RDS. But these would have put a lot of barriers to scalability in the future. So because we want to ensure this works as seamless as possible, because we want to keep an audit list, because we wanted to store these images for a short period of time, because of a lot of the compliance requirements that Service had, that we had to build this solution this way to ensure its scalability. And that's what makes the solution a little bit more special than a normal API call, which just taps into recognition, compares the images, and returns the comparison rate. Now, just one final thought on that comparison rate. So like I said, it is a percentage. Let's say, for example, you can return an 80%, for example, comparison rate. It'll be up to you and OutSystems to determine what comparison rate is a pass and what's a fail. So for example, let's say that we have the threshold in OutSystems configured to be, let's say 85%, then any recognition results that come back that are higher than 85% will trigger the pass or the success flow in your OutSystems application, however that might be. And if it was less than 85%, then that will trigger kind of the fail scenario. So an example of that would be, let's say you don't want to allow your users to continue through into your app if they hit a fail comparison rate. Then that's exactly what we would configure if you get the comparison rate less than the threshold configured. All right. So this is kind of high level of how this process flows. More than happy, of course, to answer any questions that you might have now, or if you want to drop questions in the messages section, more than happy to answer any questions. I actually see one question here. Do you have any metrics on how long just the recognition part takes? I do, actually. So it depends on how you configure it. It depends on a lot of variables, but the actual recognition rate is extremely quick. I think from the entire process, I don't think the recognition takes more than 30% of that time. The rest is taken by storing images, fetching them from S3, typing into RDS, storing that in IDS, modifying that in RDS. The recognition part itself is one of the components that takes the least amount of time, interestingly enough. Can recognition perform liveness checks? Can you explain, James, or give me a little more details on what you mean liveness, as in happen in real time? Is that what you're referring to?
So a liveness check beats you fooling the recognition with a photograph instead of your actual face.
Right. So we tested that because, of course, that's one of the scenarios that we had to make sure that AWS recognition catches. When we first started playing around with this, it would actually pass. So it wouldn't differentiate between an image and a real life person. However, very shortly after that, AWS recognition got an update, and it started to differentiate between the two. So I think it calculates some 3D sort of spatial aspect of the image, if it's a photo or it's actually a real face. And now I don't think you can fool it anymore with an image. But that's a really good question, and yes, there's definitely something that we twins. Well, I haven't tested that one yet, but I'll let you know how that one goes. If we've got any volunteers here, then please let us know.
Thank you, Soma. Stuart also had a question in terms of bias in the system towards gender, race, etc. Do you know any statistics around that?
Not that I'm aware of. To be honest, we haven't found something. So because of the 75,000 per month verifications, we get a lot of kind of scenarios and use cases and different people obviously trying the functionality. We haven't faced any scenario where we've noticed that there is obvious bias in one aspect or the other. I might be incorrect in full transparency, but that hasn't popped up for us, to be honest, or there hasn't something that been that come across in this scenario here, in this use case.
Cool. Thank you, Soma. We're at time. Thank you very much for your presentation. It was really insightful, and it's really interesting to see how all these things fit together.
Awesome. Thanks, Adam.
All right, over to you, Stuart. Let's see how we destroy our internet connections.
Excellent, thank you. And I'm glad you've raised that spectre of the internet connection, Hanno. Thank you, Osama. Great presentation on facial recognition too. Okay, so I'm going to talk about streaming via AWS S3. And so next slide, please. And this is what we're going to go through. Why are we even doing this? The solution overview, video playback, and configuring S3 buckets, and using the S3 API, and uploading files, because videos are big files. Okay, so next slide, please. So our scenario was we had to develop a system, a job application system that was accessible, which was a pleasure and a privilege to work on. So job applications would upload videos. Sorry, job applicants would upload videos, and then videos were only really to be available to the recruiter or intended recipient, so not everyone. And when a video is displayed in the application, the first frame needed to be displayed before it's played back, kind of like the skier there with the play button before you're playing. And when you do play, it needs to start immediately. So that was our scenario. Next slide, please. So we had some options with OutSystems. Well, the first option, static videos, you can upload
a video file into OutSystems resources. But there's a bit of a problem with application resources, which Hanno alluded to earlier. But every time that video is used in your application, it's going to be, content is going to be delivered through your web application. And also it's static. You can't do a new release of the software every time someone uploads a video. So that really wasn't going to work. Another option is using cloud video services like YouTube. Have videos there and play the video in a media player just via a URL. Problem there is we couldn't really restrict access. But that's a good solution often when you want to have video in your application. So we ended up using AWS 3 with private buckets where we would get a temporary URL and we'd use CORS to make sure that CORS to make sure that the web application can actually reference the URL to S3, but it's a temporary obfuscated URL so that it's only available for a certain time. So if someone steals that URL in an hour or so, it will be useless. So that's how we managed to do it with the creepiest looking smiley face you've ever seen. Next slide, please. So here was our solution. We had the web app. Users would upload, thanks, Chuck. Users would upload the videos into the application. We created our own AWS extension using the AWS S3 API, the .NET API, which we retrieved from NuGet and included in the OutSystems extension. And that would be uploaded to S3. Additionally, we would, and I think Mike Samuel is on the call, who we actually worked together on this. So hi, Mike. Yeah, went through some of the challenges of doing all of this. If someone uploads a video, maybe from an Apple phone, a MOV file or an VI file or something that might not be compatible across all devices, you want to convert that into something that's a bit more compatible. What we chose to do is use just MPEG, MPG files, and we would convert everything. If it's not an MPEG already, we'd convert it to that. Now, something that I need to be clear here, this is about streaming. So there's two types of streaming. One is where you're creating some sort of streaming format like HLS or Dash, where it creates a manifest and then a bunch of different files, and you can generate those files for different device sort of formats. We didn't do that. We used kind of older style streaming, which is progressive. So as long as the MPEG file is a progressive file, when it's displayed in the app and you just via a URL, it doesn't download the whole file. It just downloads the initial part. And then when you click play, it'll just retrieve the parts that you need. And that works. I mean, it worked really well for us. So, you know, you might say that's officially not streaming. If you did want to do that via S3, though, you can convert to HLS or Dash files and use the same method. So we didn't need it, but you can still use the same sort of architecture. Next click, please. Now, what we would do once the file was uploaded, we would request a URL from the S3 service, return it to the web application, and next click again, please. And that will retrieve the file directly from S3 using that obfuscated time-limited URL and play back in the app. So I can say to Hanno, it's not destroying the performance of your app, and I think you probably knew that already. It's actually, it works really well because it's retrieving the content directly from S3 in a secure way, and your OutSystems application is only really used for the upload part of the, and really displaying your web application. So that's the solution. Next slide, please. So for video playback, pretty easy. You can just use the OutSystems media player control. We actually used, because we had sort of really strong accessibility requirements, we used a JavaScript video player control that was fully accessible with all of our requirements. But the OutSystems media player will work for you. We retrieved that temporary URL and just put that into the media player. Now, something that we also did is we cached the URL. So every time a page wanted to display a particular video, we didn't go to the AWS API every time. We cached that based on the storage key for the file in S3. And so that was a bit quicker. There wasn't an extra leap there for a lot of the time. We had to do our CORS cause configuration so that the web application or the browser wouldn't complain getting a URL from a separate domain. As long as we do that in AWS, then you won't get an error when you try and play that file. If you do this, consider using a CDN. We didn't need one. But using a CDN, you might do that because you have people in different geographic locations than where your S3 bucket is hosted. Ours is hosted in Sydney. We were Australia-wide. But if you had someone in the US, you probably wanted to use a CDN. Even if you're in Perth, like Phil, hi Phil, you might want to use a CDN for that reason. We didn't need it though. Now that transcoding step, we used AWS's Media Convert service. There's a gotcha here. There is a transcoding service to convert video files to other formats in AWS, but it only handles a certain number of formats. And it didn't handle all the formats we needed. Media Convert does. Media Convert's the newer one. The pricing's also better. So use Media Convert. Transcode is old. Look, maybe there's a reason to use it. I don't know what it is. Next slide, please. So next, we need to configure our buckets to store our videos. Next slide, please. Probably shouldn't have put that slide in, should I? So S3 configuration. First off, we need to connect to S3. So we create an API user account. Now, when you create that, you can create two types of accounts that actually just log into the console and API accounts. So create an API account to use the API. Kind of makes sense. Record the secret and access keys. The access type is programmatic access with an access key. That kind of makes sense. And then create your S3 buckets, name them well, like my project -dev, -test, -prod. Put them in the right AWS region. If you're in Sydney, put them in Sydney. Don't put them in East US. Okay, thank you, well done. So then the bucket policy. So this is how you give access to your API keys. Don't make the mistake of saying, oh, my API key can have access to S3. That will give your API key access to everything. Do it with a bucket policy. The principle there is the AWS URI for your API user. My project dev -API, that's kind of what I used for the naming of our users. And then the resource is the bucket. So, and the action there is, what we did is we just said the API can do any action on S3. Maybe we should have restricted that a bit, but didn't. So consider that too. Next slide, please. So now, if you just did that, your video wouldn't play because your browser is saying, I'm not going to play a resource from another website. So you need to set cause configuration in AWS, in your bucket. And you put the URL for your application in the allowed origins. So just follow the bouncing balls in AWS console and put your URL in, and then you're good to go. Next, please. Right, So now we have to use an API. So connect to the API. Remember that access key and secret key? You will need those to connect to the API. You'll also need the region name. Now, I actually said region name here, but in the API, it's the kind of code, not the actual name. So it's AP-Southeast-2, not Sydney. So don't make that mistake. And you'll only make it once. And then the name of the bucket. Right, so that's connecting to S3. Next slide. Then we need to get our temporary URL. So there's a method on the, I keep on thinking actions, functions, methods, OutSystems. So there's a method on the API called get pre-signed URL. That's what you use to get that URL, and you give it the time that it expires. That's available in that S3 API that was mentioned earlier. We had to use a few extra functions, so we rolled our own extension for the API. Create a cached server action. So when you pass the key, just return the URL from there. Make sure the cache time on your action is less than the time on your URL. If the cache time on your action is more, what'll happen is you'll go, hey, give me that URL. It'll give you the URL, but the URL will have already timed out. We actually made the cache time half of the time of the URL timeout, just to make sure, because we're paranoid. Next slide, please. So now we have to upload our videos. Next slide, please. There is another useless slide. Right, so uploading files. You can use the transfer utility upload request in the API. That'll upload the whole file. We didn't use that. But I'll tell you about that in a second. You have to generate a file key. Don't use the file name, because if someone uploads file name 1.xls or MPG and then tries to upload a different file with the same file name, you'll overwrite it. So what you do is you generate a key. You store the file metadata in the OutSystems database, but then you generate a key. What we did was we used a pseudo sort of key with entity, database ID, and then a generated GUID. And we just put the extension of the file on the end. That kind of gave us a pseudo file structure in S3 as well. And it means that you don't, well, you're very, very unlikely to overwrite a file. You know, maybe in 100 years, someone might overwrite a file. So let them worry about it then. Next slide, please. Now, remember we're uploading videos. So just uploading the file in one go is probably not going to cut it, because you don't want your job applicants who want to get a job sitting there waiting for, you know, 5 or 10 minutes while the video uploads. So upload your video files in chunks and in multiple streams. So the API calls to use that are initiate multipart upload, upload part. Now, upload part actually is the bit that uploads the chunks. Upload part won't work unless the chunk is at least 5 meg in size, unless it's the last chunk. So when you're chunking your uploads, normally that's a lot larger that we would, you know, use to chunk a file for uploads, but you need to make it 5 meg or greater, and then this API will work. And then when you're complete, you call complete multipart upload, then the file is available. We had to build a custom client-side upload widget to chunk the file. If anyone kind of needs that, just let me know and I'll kind of create a Forge component. There are a bunch of asynchronous upload Forge components there, so they may work as well, although disclaimer, I didn't look at them, so they may not. All right, so that's how we streamed video in an OutSystems application. Next slide, I think, is just questions.
Awesome. Thank you, Stuart. I think you answered Helena's question there with your last slide. How do you upload large files over 250 meg? And then Rafa had 2 questions. One, which player did you use? And was DRM an issue for you guys?
Oh, which player? Oh, I can't remember. Can we sort of, I don't know if we can post anything later, but I'll go and find out and I'll let you know. It was good. Sorry.
Any chances to be Shaka player? Which
No,
is a
no, doesn't ring a bell. Wasn't that one?
Okay.
Thanks though. Did we need to use DRM? No, we didn't use any DRM. These were kind of user-generated videos as well. Thanks for the 1 minute warning. Oh, I think I went over. Sorry.
That's all right. We have some spare minutes.
Okay.
Cool. Thank you, Stuart. That was really insightful. A lot I didn't know and something I might probably use soon. Over to Hafa, who asked some questions there. Hafa, enlighten us, please. Thank you.
Thank you, Hanno. Before I start, just a brief introduction, everyone. I am Rafael Ranieri, I'm OutSystems MVP, and I work with OutSystems for 9 years. Today, I will talk about the AWS certifications, but before talking about that, I just want to talk about the importance of the cloud itself, right? As Jacques said in the beginning of the meeting, historically, OutSystems was always together or tied with the cloud, right? Since 2008, to be more exact. And in fact, the OutSystems name is because of the cloud, right? In 2014, someone asked in the OutSystems forums why OutSystems was called OutSystems. And Paulo Rosado himself, the CEO, the OutSystems CEO, answered that the idea was that they were thinking at some point the companies would start to left the data centers, right, and go to somewhere else, somewhere else. And they didn't know that somewhere else would be called cloud, so they use it out. So this is why we have OutSystems as the name. We could have the name Cloud Systems potentially. So the cloud is always, historically was always tied with OutSystems, right? With that being said, if you can change the slide, Hanno, let's talk a little bit about the AWS itself, right? As you could see on the other presentations on the topics Osama, Stuart, and Jacques said, we have a lot of services in AWS, right? So we normally have this AWS iceberg, where we say that something is built with AWS, but we never know what exactly was used. So the first point, why it's important to have the awareness and to get the certifications, is to be aware of what services and what exactly is happening behind the hood, right? If you can change the slide again, Hanno, please. So why get certified in more details, right? The first point is that AWS have over 200 services. Like we said in the iceberg, right? It's important for us to know what services are being used in the solution. It's an industry standard. It will give you visibility in the market. And the most important reason, at least for me, is that it's the future of OutSystems as well, especially with ODC. ODC is the abbreviation for OutSystems Developer Cloud, the next version of the OutSystems platform. And ODC will be using everything related to containerization. This is the difficult word for me, like Osama said. Try to say that 3 times quickly. Containerization is a very difficult word for me, sorry. But it's all about that. And on the next version of OutSystems, we will be using a lot of AWS in the behind the hood, right? So it's very important to understand what it's being used there, and how we can handle any changes or any issues we might have, even if the cloud or the platform as a service is supported by OutSystems themselves, right? It's important for us as developers to know what is happening. And finally, the final reason is to have a better understanding of the accelerators OutSystems provides by default. Okay, if you can change the slides again, Hanno, that's it. This one. Here we have some different pathways that AWS provides, right? You can notice that on all of them, the 2 certifications at the beginning is always the same, right? We have first a Cloud Practitioner, which is an optional but recommended certification. And the second one is always the Solution Architect Associate. So in all pathways, we have these 2 certifications, and these are the 2 certifications I want to explain in more details. If you can change the slide, Hanno, please. Perfect. So the first one, AWS Cloud Practitioner. This one is the easiest of the AWS certifications. It will give a very good overview of most of the AWS services. So it covers around 56 services, which is more or less 25% of all the AWS universe. So it's a very good certification for you to start understanding about AWS, of what AWS is capable of, and it doesn't require any experience, so you can do it right away. So it's a very good way to start your journey with AWS. I personally have this one. I really recommend for everyone to get it, to start getting to know AWS. And if you can go next to the next slide, Hanno. And the second one is the AWS Solution Architect, which is a little bit harder. It's the #1 certification in AWS. It focuses more in some areas like access management, virtual private cloud, S3, S2. They focus more on hands-on exercise. It also theoretically doesn't need experience, but they recommend you to have at least 1 year of experience in AWS. However, you could take it even without the AWS practitioner. It doesn't have any pre-requirements. You could go and take it right away if you are confident enough.
Awesome. Thank you, Hafa. Thank you,
Pleasure.
Sama, Hafa, Stuart, and Jacques. We really appreciate that, your time and effort going into those presentations. It's well laid out. I really enjoyed it, and I learned a lot today.
Thanks, Hanno. Thanks to the organisers. That was awesome. Well done.
Thanks, everybody. And we'll be setting up the next one in the coming weeks, and we'll start promoting it shortly. So make sure that you join us for more interesting discussion topics, and let us know what you want us to talk about as well.
Yep.
We're open to suggestions. We want to talk about the things that the community wants to hear about.
If you don't know how to contact us, find us on the OutSystems Community Forum. Send us a message there.